Myself, Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science, Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about how we are going to design the charts and graph for the presentation of data, so which comes under the concept of principles of data science. So in this video, I'm going to show about what are the contents of this presentation, so introduction concept, and what are the various ways of finding the data, and know where we are going to get the data, and what are the guide to the chart types like bar chart, pie chart, line chart, area chart, right, like that, and data design that should be doers and don'ts. So very first thing is that, so know your data first. So first, that means before understanding the visualization, so we must understand that the types of data that can be visualized and their relationship to each other. So here are the some of the common ways that you like to encounter here. So that means that, so whatever the data, so what the data it is actually, where I'm getting this. So what are the various sources of data? So the data, what are the various sources of data? Like I covered some of the videos, so also may go through it in that one. So normally the data is going to get from different sources, like primary and secondary. So primary means where one-to-one interaction, and mm, um, questionnaire, like this I can able to extract the data through primary source. And when it comes to the secondary, it may be textbooks data on newspapers, like that. So these are all data what comes under the secondary one. So know our data. So once the data we know, so whether it is a primary or secondary, so that data is going to be classified into types of data. So types of data means where it should be a quantitative data, or it may be discrete data, or it may be continuous, and it may be categorical. So like this, we have to be classified the data into different types. Okay. So quantitative means where the data that may be counted or measured. So all the values should be numerical here. And discrete means, so here the numerical data has a finite number of possible values. So example, number of employees in the office. And continuous means, so that means the data that can be measured has a value within a range. So example, rainfall in a year. And categorical means the data that can be sorted according to the group or category, like the types of products sold. So like this, I can able to classify this data into different categories. So very first thing is the quantitative. So quantitative means that, so the data that maybe have measurements. Suppose if I'm going to take height, so that I can able to measure in centimeters, and weight, and kgs. So this and all will be considered as a quantitative. Okay. So qualitative is under kind of the thing is there. So here the data may not have any kind of measurements. So that thing will be considered as the qualitative data here. So like this, we maybe have a discrete also. So discrete in the sense the numerical data has a finite number of possible values. So like number of employees in the office. So the count, like number of employees, a number of students, okay, that and all will be considered as the discrete data. And next one is continuous. So that means that, so the data is going to have some measurements. So okay, but have values or measurements. So what the data is going to be with respect to time, it is going to be measured. So like rainfall in a year, what it is. So in rainfall in a year means, so in 2001, how many centimeters of rainfall? Like 2 centimeters. And 2002, 2003, like this, it is going to be changed. So with respect to the time here, okay, that should be the continuous. And next one should be is a categorical. So here the categorical means where the data is going to be sorted according to the group, or it may be a category, like number of products sold, like this. So these are the different types of data. And next one, data relationships. So next, once the data is divided, so what kind of relationship that the data is going to have how to be known. So that means that nominal comparison is there. So nominal comparison means it should be a simple comparison of the quantitative values of subcategories and number of visitors to the various website. Like example, and time series means this is going to be track the changes in value of consistent metric over the time, like monthly sales. And the correlation means this is the data with two or more variable that should be demonstrate positive or negative correlation with each other, like salaries according to the education level. And ranking, it means it should have two or more values that should be each other, like historic weather patterns rank and from the honest month to the coldest. So ranking should also be there. And then deviation, that means how the data is going to be examined to each other, and that should be vary with respect to mean, like amusement park tickets sold on rainy days versus regular day. And distribution, so distribution means this should be the data distribution of the central value, example heights of players of basketball team. And part to whole relationship, so this is going to show the subset of data compared with the larger whole, and that means the percentage of customers purchasing the specific products, like that. So here this should be the data relationship, so which is going to be known like uh, which may be in the nominal comparison, time series comparison, correlation, ranking, part to whole relationship, distribution, and deviation. So these are the different types of data relationships we have to maintain here. So just now what I said. So here should be the nominal one. So nominal means it should be a simple comparison quantitative values of subcategory. So where that thing should be to, like number of visitors to the various websites. Suppose so in India, how many number of foreign visitors? Let it be 20. In America, how many it should be 35. And Africa, how many it should be 30, like this. And time series means this should be able to track the changes of consistent metric over the time. That means the monthly sales. So what should be the sales in January, and number of sales in February, and number of sales in March, like this. Okay, I can able to know. It should be the going to with respect to time here. And correlation, so correlation means if I'm going to take two or more values, so that should be able to demonstrate positive no relation with each other. That means the salaries according to the exhibition level. And ranking, this shows two or more values that should be compared to each other in relative magnitude, like historic weather patterns rank from hottest to the coldest. And deviation, which means that here it should be examined uh, how to calculate with respect to mean deviation. That means that amusement park tickets that is going to be sold in rainy and regular day. So I want to calculate the mean of that, how many percentage, or I'm able to do that standard deviation also. and distribution should also be done. So should be example for heights of players on basketball team and part to whole relationship, which means that the subset of data is going to be compared with the larger whole. That means the percentage of customers purchasing the specific products. And next one, so what are the guides to relationship? Here should be like a bar chart, pie chart, line chart, area chart, scatter plot, bubble chart, and then heat map. So these are the some of the charts that are available to show the data visualization. Very first thing is the bar chart here. So here the bar chart should be very versatile, and they are going to be a subset, or they are going to be a best used to show the change over the time, compare the different categories and compare the different parts of whole. So the variations of bar chart may be page views by month, and number of page views in a month I want to know, so how can I able to show it? So it may be a bar chart. This is the suitable one, so I can able to know how many number of viewers in January and how many number of viewers in February and how many number of viewers in this one. So this should be a vertical. The tabs also going to be available, horizontal bar chart, and next one is vertical bar chart. So these are two types of categories. This is the vertical one, and this should be the horizontal one. So the times actually this bar chart should be very versatile, and these are the best used to show over the time. So which is going to be compared the different categories or maybe a different parts of the whole, and there should be content published by category if I want to show you should be also be represented in the form of horizontal one. So normally these horizontal bar charts is going to be used for the longer categorical levels. So number of educational information, entertainment, through leadership I want to know. So similarly, there should be a different variations of bar charts also available, like stacked bar chart and 100% stacked bar chart. So stacked bar chart means where within the bar itself I can able to divide it into different portions. Okay, like email marketing, how much it is, organic search, how many it is, and paid search, how many it is. So this type of comparison also be done in a bar chart. So, but it should be used when there is a need to compare multiple part to whole relationship, and these can use discrete and continuous, either horizontally and vertically. And the next one is that stacked bar chart. 100% stacked bar chart means here the data is going to be mapped with 100%. So that means all the bars should be mapped to the 100% equally. Like this different portion, but it should be not just 100. All the bars should be of equal maintenance. And this should be used when the total value of each category is unimportant and the percentage distribution of subcategories to convey message. So, what are the best ways of designing this bar chart? What are the do's and don'ts we should not do? So, the very first thing should be use horizontal labels. So, instead of using the vertical one, and the space bar should be appropriate. So, equally, we have to maintain here half inch exactly, and state the y-axis value to 0. So, all the time we have to specify 0 here. So, instead of representing other values, and use consistent colors. So for this, don't use of different colors like this. So consistent should be there, and order the data appropriately. So don't use so apple, oranges, bananas like this. So alphabetically have to be arranged like A alphabetical A B O like this. So this should be a exact order. That's why it should not be considered here. So these are the some of the design best practices we have to be done for implementing this bar chart. Okay. So first we have to be done should be horizontal labels. So that means avoid the steep diagonal or vertical tab as it is difficult to read. So if I'm going to specify that like this, so what will happen is it should be difficult to understand how to be rotate your head and then to study like this. So that should thing will be little bit difficult. So you have to represent the data in horizontally only. And spaces. So equally distribution of spaces should be done between the bars. And next one should be uh, specify this 0 at the axis and use the consistent colors. Don't use of different colors and order the data alphabetically. So next one is pie chart. So normally this pie chart is going to be used for making a part to whole comparison. So with the discrete and continuous data. So normally they are the most impactful to the smaller data set. So the variation of pie chart should be the standard and then don't. So it is used to show the part to whole relationship, and don't mean stylish variation that enable the inclusion of total value and design at the same time. So the pie chart is the most commonly used popular data type. So however, some of the cases may arise. So in a particular portion of part to whole relationship, I want to maintain how much of segment it is, and that kind of thing. If I want to go for the application, then I have to consider the pie chart here. So what are the design best practices for the pie chart here is that so visualize no more than 5 categorical per chart. That means that if I'm going to consider the more number of elements, so it should be a little bit clumsy, and then we should not clearly estimate how much of value it is here. And so if I'm going to consider only some little part of elements or little number of elements, so that the portion is going to be specified very clearly, and how much of percentage it should be like this I can able to clearly understood here. So that means so visualize not more than the 5 categorical elements. That means so it should be a difficult to differentiate between the smaller values. So depicting more slices would be decreasing the impact of visualization, and if needed, so you can able to group the smaller values into other or miscellaneous category. And next one is that so don't use the multiple pie charts for comparison. So that means the slice sizes are going to be difficult to compare side by side. So using a stacked bar chart instead. Okay. And next one, make sure all the data adds up to 100%. That means so whatever the percentage of portion here considering, so that should be matches with the 100%. So look at here. So 20, 15, 35, 45, 55, 55. So it should be mapped to 55, but here it should be 100. So the percentage should be matches with the 100% only. So make sure that all the data adds up to 100%. So verify that the values and pie slices should be size proportional to the corresponding value. Next one, ordered slices correctly, and option 1 and option 2. So that means we have to be uh, giving this ordering slices count, either it may be in a clockwise direction or anti-clockwise direction you have to be considered. So they should be the clockwise direction and they should be anti-clockwise. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this type of consideration should also be considered while presenting the pie chart. If I'm going to go, this is 1, this is 2, this is 4 like this, it should be a little bit confusion. So wait, what is the first one, what is the second one, like that. This kind of thing we have to be considered here. So pie chart means, so here what you have to do is that all the time you have to be follow the design practices for the pie chart as well. So that means visualize no more than 5 categorical elements and don't use the multiple pie chart for comparison, and make sure that all the data add up to 100% and order the slices correctly, which may be a 2 or they follow clockwise or anti-clockwise direction. And next one is the line chart. So line charts are going to be used to show the time series relationship with the continuous data, and this may also help to show the trend, acceleration, declaration, and volatility. So the direct marketing I want to know. So how much of uh, marketing views is going on. I want to know 5-1, 5-2, 5-3, 5-4 like this. So what are the design practices we have to be followed for the line chart here? That means, so include a zero in baseline if possible. So that means what is the line chart we are giving, the axis is important. So all the time the axis should be pointed out with zero and it should not be specified some other thing at the axis point. So don't plot more than 4 lines. So if I'm going to draw the line chart here, so we should be not more than 2 lines. So if I'm going to consider the more number of lines, so a lot of disturbance is going on in that one. So and use the solid lines only, no dotted lines. So this is another kind of design practice we have to be considered in line chart. And label the lines directly. So what is this line meant for? Don't use orange, blue, and red. What is meant for like this? So here itself we can able to specify so that we can able to see the data exactly and use the right height. So if I'm going to decrease the value, the height is going to be looks good here. So if I'm going to decrease the value, then it should be a little bit a straight line almost all here. So these are some of the design practices we have to be follow in line chart. So that means, so include a zero in baseline if possible, and don't plot more than the 4 lines, and use the solid lines and label the lines directly, use the right height. So that means include zero at base possible so that number of fluctuations should be meaningful, and you may also truncate to show the base variations. And don't plot more than the 4 line. That means if we need to display more, then you have to be separate the chart for the better comparison. And dash and dotted line should also be make it distracting. And the lines, label the lines separately. That means you can able to quickly identify the lines and corresponding labels instead of differencing or lizard. And plot all the data points so that the line chart takes up approximately 2/3 of the y-axis should be total scale. So area chart is the other variations of area charts. So new contacts by source, and I want to show it. So what is the area chart means? Area chart is means best used to show the compare a quantitative progress over the time, and best visualize part to whole relationship, which is helping to show the different category contributions to the cumulative total. And 100% stacked area means which is going to show the distribution of categories as part of whole where the cumulative total is unimportant. So area chart depicts the time series relationship, but they are different than the line chart for that. So area chart, stacked area, which should be have different variations. And 100% stack should be matches the almost a rectangle, and you can able to show this. So what are the design practices we have to be follow in this area chart? So first thing is that make it easy to read and start by axis value at 0, and don't display more than 4 data categories, and use the transparent colors, and don't use area charts to display the discrete data. So very first thing, make it easy to read. So in stacked area charts, arranging the data to the position and categories with highly variable data on the top of the chart and low variability to the bottom. And the start by axis at 0, that means the starting the axis at 0 truncates the visualization values, and don't display more than the 4 data categories, and use the transparent colors here. So in the standard area chart, ensure that it is not obscured in the background by altering through the using the transparency, and don't use the area chart to display the discrete data. So starting the axis above the 0 truncates the visualization value. So specify 0 so that it should be better, and don't display more than 4 categories. If I'm going to show more than that, so it should the result should be little glittering, or it may be something difficult to study. And use the transparent color so that it should be background should be very ensuring this data is not going to be absolute. Next one is don't use the area charts to display the discrete data. So the connecting lines imply the intermediate value, which may also exist the continuous data. And next one is scatter plot. So scatter plot is also going to show the relationship between items based on two set of variables. They are going to best use for the showing the relationship in large amount of data. Uh, Suppose revenue by product family I want to show. How can I able to put? So what are the design practices we have to be follow here? So same thing, start by axis at value 0, so that the starting the axis above the 0 truncates the value visualization of values, and include more variables. So it is used size and dot color to encode the additional data variables, and use trend lines. So this should be help to draw the correlation between the variable to show the trends, and don't compare more than 2 trend lines. So too many lines able to make the data difficult to interpret. Okay. So the design practices should be start by axis at the 0. So in scatter plot we have to be show instead of lines and the batch charts. So what we have to do, we have to simply put the dots. So include more variables so that it should be use the size and dot color to encode the different data values. So if I'm going to use different colors, what is the data is meant for, it should be clearly understood. And use trend lines so that it should be to show the correlation between the variables, and too many lines also make it difficult to interpret. And next one is bubble chart. So bubble chart is also another kind of variation. So the bubble chart is also good for displaying the nominal comparisons or ranking relationships. So normally this bubble chart is also nothing but a scatter plot. So instead of presenting a dot here, so we have to represent a bubble, which is the best value to show the additional value variables. And bubble map is also another kind of the thing. So which is used for visualizing the values of specific geographical regions. So bubble and bubble chart, bubble map. So both are different. So here the visualization values for specific geographical wise I want to show, then it should be a bubble map here. So in map itself I can able to show biggest number of cells in which under areas it is, which under continents, like this I want to show. Then it should become the bubble map. And next one is design practices. So what kind of design practices have to be done while implementing this bubble map and bubble chart? So make sure the labels should be very visible and size the bubbles appropriately, and don't use the odd shapes. So all the layers should be unobstructed and easily identified with the corresponding bubble. So here the size bubbles are appropriate. So that means, so either I can use 1 and 2x, and not that much of a big size you have to be done. So little bit size. So the bubble should be scaled to according to the diameter. And don't use the odd shapes. That means, suppose if I'm going to show the dollars here, I want to show the dollar symbol, it should be not preferable. So all the time it should be good for the purpose. So these are the some of the design practices what we have to be follow in this one. And heat map. So it is the another kind of visualization which is going to display the categorical data uh, using the intensity of color to represent the value or geographical areas of data tables. So here it should be state with the new service contracts I want to show. So I can able to show this with the rectangle, some other shapes, how much of it is intensity of the color, going to show the values of geographical areas of that. So what are the design practices you have to be follow for heat map? So for that use a single map outline. So these lines are meant to frame the data, not a distract one, and select the colors appropriately. So some colors will stand more than other colors, so giving that unnecessary weight to the data, like this. So what will happen instead of that, use a single color, so with varying shade or spectrum between the analogous colors to show the intensity. And use patterns sparingly. That means that a pattern overlay that indicates the second variable is accepted, but using the multiple is something different, right? So if I want to show some particular part of the something different is, you can also use some other different kind of patterns also. And choose appropriate data ranges. So fix, so not 75 to 86 and 82, and it should be 7. The ranges are different here. Don't use that choose only appropriate ranges, 75 to 77 to 78, 89 to 80, and 80 plus. Choose the appropriate data ranges. This and all will be the data ranges value. So the design practices should be good for simple map outline and select the colors appropriately. So some colors standard more than going to be unnecessary weightage, so that avoid that. So select colors appropriately. So we can also use some different kinds of patterns for showing or highlighting the content, and choose appropriate data ranges. Don't use the different data ranges, which may also lead to different problems. So the next data design do's and don'ts will be, so designing the data that does not have to be overlapping, and with the basic of understanding how the different the data set should be visualized, along with a few fundamental best and practices, so that that should be accurate. So the very first thing should be, don't use one color to represent the each category, and do order the data sets using logical hierarchy, And do use callouts to highlight the important or interesting information, and do visualize the data in a way that it should be easy for readers to compare the values, and do use icons to enhance the comprehension and reduce unnecessary labeling, and don't use high contrast color combinations such as red, green, and blue, and don't use 3D charts, and don't add chart junk, unnecessary illustrations, and drop shadows or ornaments and sticks and distract from the data, and don't use more than 6 colors in a single layout, and don't use distracting fonts or elements. Okay, so these are the some of the do's and don'ts that should be applicable for designing the data here. Okay, so here what I have to do is that, so all the time we have to be use a single color for representing the each category. Don't use that high number of contrasting colors, such as red, green, blue, and yellow. So do order the data sets using logical hierarchy, but here don't use that 3D charts. So it should be skewed perception of visualization. And next one, don't use the callouts or highlight the information and interesting information, but don't use the chart junks and all unnecessary illustration, unnecessary drop shadows, ornamentations from the data. So do visualize in a way that should be easy for the readers to compare the values. So do use more than the colors in a single layout, don't use that. And do use icons to enhance the comprehension, but don't use distracting points of them. So these are the some of the data design do's and don'ts you have to be followed. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.